Okay, welcome to the August 1st, 2020 presentation at the SNARS meeting. We're having this is Barry K6ST, I'm your moderator today. We're having a great conversation and some demos on 3D printing for applications for ham, radio, and beyond. So before we actually start, I just wanted to introduce our esteemed speakers. So Tom, W6XX, go ahead and introduce yourself if you would.
Good morning, everyone. My name is Tom Holbert, W6XX. I'm over here in Sparks, Nevada. And I got a few things to show you that I've made and designed and show you my printers.
Okay, great. Thanks. We'll get to you in just a minute. Now let's go to Ken, K7KBJ. Hey, Ken, you want to introduce yourself?
Good morning, everyone. This is Ken. I'm out in Palomino Valley this morning, and I'm going to today be covering the design aspect of 3D printing. If you have a 3D printer, you can print virtually anything, but if you don't do your own designs, you have to get them off the internet or from a friend. So I'm going to cover the actual design aspect. Thank you, Barry.
Okay, great, Ken. And Hunter, you want to introduce yourself?
Good morning. I am Hunter, KJ7IRS, and I will be showing some of the software you need in order to print, as well as some competitions you can do.
Okay, super, Hunter. Thank you. Thank you so much. So just on the screen here, we have a little piece here of on the facilitator. We have Tom, Ken, and Hunter, so you can get hold of any of us. So the way this came about was, I don't remember, maybe you remember, Hunter, but I think you and I were on the air one day, and I said, what have you been doing? That's interesting. One thing led to another. We came to the conclusion we could do some sort of presentation on it. I put it out to a few people. One person led to another person, and here we are today. So that's very, very cool. Thank you, Hunter. The other thing is, when people registered for this event, we went ahead and asked people a question. You know, how familiar are you with 3D printing? Number 1, nothing. Number 2, little. Number 3, medium. Number 4, a lot. Number 5, expert. And what's so interesting is, as the numbers came in over about a week and a half, people registered, and we're up to 52 on right now, which is a big turnout today. It turns out that something like close to 30% of the registrants for today's event said they know nothing, and about 50% said they know little. So if you add those together, it's about 80%. So we have 80% what I'll call beginners, and then the people that are medium, a lot, and experts make up about 20%. So we're going to do our best to give you sort of the applications of it and how it makes sense. So to start off, particularly for those that know very little, I'm going to show you a little video, a couple of minute video, sort of a little bit of overview of this 3D printing, what it is. Okay, let me just get this up. It's about a 2-minute clip here. So let's get this going. Okay, here we go.
3D printing technology is already changing the way we produce objects, from tools and toys to clothing and even body parts. 3D printing is part of a process known as additive manufacturing, where an object is created by adding material layer by layer. Additive manufacturing allows designers to create complex parts for machines, airplanes, and cars at a fraction of the cost and time of standard means like forging, molding, and sculpting. Now, smaller, consumer-friendly 3D printers are bringing additive manufacturing to homes and businesses. The first step in 3D printing is to create a blueprint of the object you want to print. You can use modeling software like Blender to create your own designs, or you can visit websites like Thingiverse or Shapeways to find objects other users have 3D modeled. Once you have a finished design, it's time to send it to the printer. Some printers, like the MakerBot Replicator 2, have renewable bioplastic spooled in the back of the device, almost like a string. When the printer receives the data, it pulls the material through a tube, melts it, and deposits it to the plate where it instantly cools. As you can see, the 3D object is created through layering, where the printer will add one layer of the object at a time until you have a fully formed structure. The most common material used in 3D printing is plastic, but the use of some other materials allow for the creation of some pretty amazing products beyond simple tools and toys. 3D printing food is becoming very popular, and additive manufacturing has allowed for the creation of some pretty intricate treats. In the medical world, doctors are testing biomaterials for regenerative medicine. By using a patient's cells, doctors could 3D print small body parts like ears and noses. Some surgeons have even tested 3D printed organs for transplants. Recently, giant 3D printers in China printed 10 houses in just one day and at a cost of less than $5,000 per house, proving just how cost and time-efficient 3D printing can be. For more on 3D printing, check out Mashable's latest coverage. And don't forget to watch the other videos in our Mashable Explained series. 3D printing.
Okay, so a little overview of 3D printing. I thought that would be helpful. Okay, we're going to take a little poll here to kind of see where people are at. So let's just see here. Get this poll running. Okay, so the first poll that you should see on your screen is, do you have any products made from 3D printing? So a product is the output. So it could be anything, whether it's ham radio or not. It could be a little end insulator. Like I have a plate that Eric made for me that goes between a radio and a head. So do you have any products, meaning outputs? And give it another minute or two, and we'll do sort of that. Okay. I think we're done. So let me end the poll. And let me share the results. So this is what we have. Can you see that okay, Hunter? The results there? So do you have any 3D printing? About a little over a third of the people, 37% said yes, and 63% said no. Okay, interesting. I'm going to take a second poll, and the second poll is going to ask, okay, question is, do you have a 3D printer? So either you own one, yes, that's number one. You don't own one, but you have access to one. Maybe at the library, some people were talking about. Somebody said Washington County has 3D printers, training is free. Or no, I don't. Okay, well, we're getting the results pretty darn quick. And when our presenters do their presenting today and talking, you guys can talk about the printers and what they cost and all that stuff. Okay, so here's the results. Pretty interesting. About 10% say they own one. About 10% say they have access to one, and about 79 or 80% say they don't. Okay, very good. So the way we're going to do this today is we're going to do about, I'm going to shorten your time just a little bit, guys, so we have time for a little question and answer. You can do about 8 minutes a segment. So we have Tom's going to start first. He's going to talk about some applications of 3D printing and show his printer for about 8 minutes or so, 8 or 9 minutes. Then we're going to go to Ken Case from KBJ. He's going to show about designing, and then Hunter's going to show some things about some applications, printing, slicing, and competition. Then we'll have a little time for Q&A. Then we're going to end the meeting hopefully at the end of the hour or top of the hour. People can leave if they need to, and then we'll have a Q&A session. Okay, so let's send it over now to Tom. Hey, Tom, I think you have video at your place there, so go ahead and I'll put it on, I'll lock it on your screen so you can show some cool stuff. Welcome, Tom.
Very good, Barry. Thanks. Yeah, I'm going to show you a design that I made based on a problem that I had with this arrow antenna. I bought an arrow antenna, and unfortunately I bought the Alaskan arrow, which is another like 1.5 feet longer, and it adds a lot of weight and awkwardness to trying to hold the antenna and trying to do satellite work at the same time, while working your radio and, you know, trying to follow the sky. So, you know, it was a simple idea, and I looked on the internet and found some stuff and kind of based a design off another design, which I'll show you later, but let me turn this around. And there's the antenna, and it's on a tripod. So it solves my problem of having to hold the antenna and work the radio at the same time. And it's on a tripod head, walking closer, that can be, you know, tipped in 2 different axes. So it enables you to tilt the antenna towards the sky and pivot it in a 360-degree axis. So it works pretty well, and it has several other uses. I mean, if you're out camping, it's great. You can set it up and have it somewhere else besides your campsite, or for SOTA work. You know, it's a great antenna. Just point it in the right direction and call away. So, you know, it's kind of been a work in progress. I'll point down to some of the revisions I've made. You know, here's one of the newer ones, and made one with a pad so you could put the pitch and slope meter on there easily and not have it duct taped to the top of the mount. The mount has since evolved into something a little greater, but this is the way it mounts to the antenna. It works great, and you can move it along the antenna pretty well in different, if you want to orient the mount on a different element. So, so that's one problem that was solved. Another one, here's another mount for it's for the ATAS 120A, and there's a couple of different applications. This one goes on the antenna mount. It's got the, I think it's a 3/8 knurled fitting that goes around top of the antenna mount, and the ATAS 120 slips right in that hole with your elements attached there. And it works okay, not the greatest, but if you want to remove the thing from the truck, it works pretty well. Other things, and this is something that I've downloaded, is a faceplate mount for the 857 faceplate. And with the holes, it allow you to mount it to like the bottom of a countertop, or, you know, to the wall with the holes for your wiring to come through. That was kind of handy. I haven't really used it much, but you know, there's a lot of other things for ham radio, you know, that 3D printers can make. I've made a DVM box, which was I had at the last NVCon, and basically it just takes your standard screen DVM, which is about that big, and makes it into a 3.5-inch screen. And it's fairly easy. You just buy the screen on Amazon or eBay, and it's 4 wires. So you take your DVM out of its metal case and solder it up. There's a little bulkhead mount there for the antenna, and there's a USB. I'm kind of shadowing the light, but there's a USB connector there. So you have very little parts to complete a project like that. I think the screen's about, you know, $20, $30, and all the little mounts are nickel and dime stuff, $2 here, $5 there. So all in all, you know, $50 plus the couple hours of print, you've got a modified DVM where you can actually see the display. I've obviously got some radio holders, which some of you bought from me for the Anytone. They work really handy. And I built one for Bill for the VX6, but it holds my FT3. So it's a slick little holder. And other things, I guess, would be call sign placards. I made a dot call. And it works. Had to do a little bit of filing, but it was pretty slick. Something I thought I would make, and just to see if it could be done. And another thing is a can lid. Now, if you're ever out camping, this is something other than ham radio, but you know, sodas and beer and ham radio go hand in hand. So camping, you're outdoors, you don't want to swallow a bee because that would pretty much ruin your trip. And there's a little can cover. And that keeps things out while you're not sipping away. Other things I've made, I've been breeding birds outside of, this is again outside of the ham radio scope, but these auto egg turners. So when they're in the incubator, they rock back and forth with the eggs. And this was also a design I got off the internet. I have another one that I modified because some of the strength in these legs was not quite sufficient. So I put in some bracing on the mechanical software that you're going to see from Ken, the modeling software, and made it a little stronger, reprinted it, and modified this servo slot so it fits the servo more appropriately without having to do grinding and sanding, which this material can be drilled, sanded, cut. I mean, it's very durable. It handles the weather. I've left this stuff outside all winter, the antenna mount for the ATAS 120, and it took it well. It's amazing. I'm using a polylactic acid filament, and that's what I'm printing a demonstration here of the Arrow antenna mount. I wanted you guys to be able to see what this machine looks like in progress and be able to see the inside. Because what appears to be solid from the outside with these prints isn't. 9 times out of 10 it has an infill, which gives it strength but allows the part to be semi-hollow. It's still, enabling its strength integrity. So this thing's about halfway done, and it's exactly the same as this one. This is what it'll look like when it's finished. And this is a working model. It has the insert, and it's ready to go. So there's a lot that can be done with ham radio and 3D printing, of course. And just your mind, you got to be able to measure things, find out what you want to solve, whatever problem you want to solve, and then measure things and draft them up, and then send it to the printer. And it doesn't always go perfectly the first time around, but the printers will print nonstop and all overnight. Once you have them set, they really don't need to be babysat too much. Some people watch them on cameras remotely, which would be fun. Then you can see problems if they arise along the way. But basically, if in 3D printing, you just need to get your bed level. You need to have a little gap between the nozzle and the plate. In 4 corners, you can level that out. And then your temperature and speed are basically the other variables that you need to pay attention to getting a perfect print. So you don't want it too hot, you don't want it too cold, and you don't want it too fast. Because it's just a matter of finesse to get the printer and and what you're making to print smoothly. Because different objects take different speed and a different temperature. So it just depends on the size and the shape of the object printed. And the time can range anywhere. This is 5 hours. But on my old setup, this would take, greater than 15 hours. So you can modify these printers depending on, how you want to suit your needs, how fast you want to print, how big of a model you want to print. But there's really not a lot of holdback from what you can do. There's a lot of things on the internet. There's several sites where you can just type in keywords like in Google. And, say you type in Yaesu VX6, and it'll pop up with, different holders for it, knobs, just different accessories that you can find useful, and then maybe you have a broken part you can replace. So the more the time goes on, the more people post things, and you can get ideas and you can share ideas. So it's really a nice way to do it.
Really great. One question came up, and then we'll go over to Ken. The question came up. Rick asked at K9THO, what is the DIY, do-it-yourself basic kit entry cost? In other words, what's the cost to get in? Can you talk about that for just about 30 seconds, and we'll go over to Ken?
Sure. The do-it-yourself kits is basically, let me flip this camera around. We'll discuss what you discussed earlier, Barry, about this printer right here is an entry-level printer. It's called an Ender 3, and it's on sale right now, I guess Ken said, for $170. And that's really, really cheap for what this thing does. This little printer I bought over a year and a half ago, and besides a couple of, like, a month hiatus or two, getting frustrated with different things, it's been running for over a year, like night and day, and it's a workhorse. There's very minimal preventative maintenance. It's a very easy assembly, and you have very good access to see, you know, what's going on the print bed. Whereas some printers, you can see straight on, but you can't see from the sides, which kind of gets tricky when you're laying your initial layer, which is the most important layer in the whole print. Like building a house, if you're off 1/8 of an inch on one side, well, that's going to be like 3 inches on the other. Could be if it's a big house. So you got to have the level nice and square in order to start. And these printers are right out of the box. There's some assembly, but it takes about an hour to put together, and you're ready to go. You know, very simple to get started.
Super. Thank you so much for the applications of this. Thanks, Tom. We'll come back to you maybe at the end if we have time, or for the Q&A. We're going to go next over to Ken, K7KBJ. Ken, you want to bring up your screen share and talk a little bit about how the design works?
Absolutely. Good morning, everyone. And before I get into that, here's the web page for the Creality printer Tom mentioned. $167 on sale. And that's the printer that he showed in his screenshot there. So if anyone has any questions about that, then we can cover that in a little bit. So my portion of the meeting today is to briefly show how easy it is to design a part. And I'm going to go through this rather quickly because I'm familiar with the software. This is the software I use. It's called Design Spark. Absolutely free download. No licensing fees. You can get a copy for yourself and go to work. That's a really wonderful tool. So using Tom's example there of the Arrow antenna mount, that's a perfect example of something that is a need, and we can fill that need very easily. So I'm going to go through that now, and we'll show the design process. So we just start a new design here. And in the 3D world, you have the X, Y, and Z axis. So we'll just start designing this mount for the antenna. And what I did is I sketched it up by hand ahead of time just to help me through the design process, but you don't have to sketch it up beforehand. You can just design as you go with this software. It's that simple. So keep in your mind's eye what you saw from Tom's video there, and we're going to start creating that right here. So I'm going to start with a rectangle, and I know it has to be 3.625. Oops, 625 by 1.365. And there's my just a 2D sketch. I'm going to go into 3D mode now. And I know the thickness of my block has to be 1.93 inches. So I just pull that up to 1.93 inches. And there's my block of material that defines the outside of that mount that you saw. So what we have to do now is put that square hole through the end face here. So I just select that face, tell the software I want to sketch on that face. And we're going to throw up a construction line here to use as a location device for my square hole. So now I can offset this construction line 700 thousandths down because I know that's the center of where I want the center of my hole to be. And now I can draw another rectangle. And I know that my hole going through this part is 800 thousandths by 800 thousandths. And I can go back to 3D mode here and simply extrude this through the part. And as you can see, now I have my square hole going through the part, and that's where the mast of the antenna mounts. Now you may have noticed that the antenna has an element that comes out through this block as well. So I need to draw that on here. I'm going to select this face, sketch upon this face. I'm going to use construction lines again to locate my hole. And I know that from the top of this block, my hole wants to be 710 thousandths down. So I just offset this construction line. And I know that it wants to be 1.1 inches from the front edge here. So I just draw another construction line. And I'm going through this stuff rather quickly, and we're going to have a question and answer period at the end here for anyone who wants to stick around and get some more information. Now I'm going to offset this line 1.1 inches because I know that's where the center of my hole wants to be. Okay, now I have an intersection here. I just draw a circle. The diameter of my element, or the diameter of the hole, wants to be 315 thousandths. Go back into 3D mode here. And I can extrude this hole through my model. And now I have a hole going through there for the element. And we're almost done. Remember, we want to mount this to a tripod. So I'm going to sketch on this bottom face now. And one of the neat features about these design tools, this one anyway, it knows where the center of my block is. So that's a great place to put the hole for my tripod mount, right there in the center. So I can just draw a circle right there. And I know the diameter of this mount hole wants to be 550 thousandths. I'm going to use a nutsert, and I'm going to show you what that is in a moment here. So this hole wants to be 550 thousandths. And go back into 3D mode here. Now I have a circle there. And I know that this counter bore is 400 thousandths deep. So I just extrude it 0.4 inches. And there's the counter bore for my nutsert for my tripod mount. Yes, you can model threads in the plastic, but over time those won't last very long. So a lot of us use these brass nutserts, and we insert those with heat. This is a good example of a brass nutsert and how they're inserted into a plastic model. And this is exactly how it's done right here, using a soldering iron tip. Just press it into the hole, let it cool for a moment, and it's done. It's that simple. Nut certs are very handy tool to for the 3D modeler here. So we're done here with this model, and I could send this file to my printer now, but I'm going to do a couple other things here very quickly, because when you're out in the field and you're putting your antenna together, you can maybe have some difficulty putting it into the hole. So you can very easily put a radius on every edge, and it will facilitate the entry of the mast into this square cutout. You can also do the same thing with the holes where the elements are going to go. You can put a small radius on those, and when you print this on the 3D printer, that radius will be in your design. And you know what? There's my model. It's all done, and it's ready to be saved to a disk, to a thumb drive, or you can upload it directly to your 3D printer using a USB cable, if that's the way you communicate. But there we go. There's the model, and we're all done.
Really good. Thank you, Ken. And as I understand it, and tell me if I have this accurate, that Tom had originally done the design, done a few iterations, and he sent you the file, and then you looked at it and then changed some things or redrew it or showed us how it's drawn. So is this correct that you can take a template and share it among a template or a file and share it among people?
Absolutely. That's how we do it. I could save this and send it to Tom, or just give him the output, and that's very simple to do. You just click up here in this software and create an STL file right here. Save it to disk, and you're good to go. You send it to the printer. And I think Hunter's going to show us how that slicing is done.
Great.
And
I just
I'll be around for questions.
Yeah, really good. Thank you so much, Ken. I'm going to have stop the screen share now. So thank you so much for that. Hunter, over to you. Let me just see how we're doing on time. You probably got about 8 minutes or so. We're going to run a little over the top of the hour. If anybody has to leave, please do so. Hunter, all yours. Welcome.
Can you guys see my screen?
Yep, we sure can.
Okay. So just one other thing I wanted to go over is another design platform that I use often is Tinkercad. It's a bit simpler and basic, but you can do an infinite number of designs really fast, and it's online, so that's nice and handy. So over to slicing programs. Once you download your 3D design, you have to slice it into layers first, so then you can print it off your printer. And one of the nice programs is Ultimaker Cura, because it has so many printer options you can add to it. So it's just so nice. And you just go up, open a file you have. It has to be a certain file type, which is like STL. So you can export it off of those programs like Tinkercad and DesignSpark into STL files, and then you can slice it, but you have to make sure all your settings are correct, which sometimes can be a bit difficult. So you have to make sure it's the right head. Then you can adjust your quality, which is like the height, the shells. And then infill, what Tom was talking about, where it's hollow inside, this is the infill. And you can make it different designs, different patterns, all sorts of things. So I'll just do cubic. And the higher density you're getting, the smaller your infill is going to be. And eventually when you get to 100%, it's just going to be solid. And that's better for hard designs. So now we can just slice it. And then it is sliced and it gives a prediction about how long the print's going to take down here. So that's another nice thing. And you can go up to the top and go to your preview of what it looks like. As you see here, there's all sorts of layers, and you can go down through the side, go down in the layers, and it shows you the infill here. And sometimes if you have an overhang, you're gonna need a support to hang that overhang on. So here, let me give you an example. This is a different program I use for my 3D printer. It's called Xyz Print, and it's just a little bit different. And so right now I'm just making the object bigger so you can see the support. And it's just normal. You have to enable supports, and you can have rectangle, follow contour, or honeycomb. Rectangular is usually the easiest because it comes off nice and easy. Honeycomb and follow contour are a bit more clustered towards the print, so it's a bit harder. And come on, load. If you can see here, the red, that's the support. It will just support it so it's not all droopy when you're printing. It'll make it nice and solid. And once you're done with it, you just peel all the supports off and you have a nice finished print. Like here, I'm stopping my share, and if you can see on my screen, I got a few prints here from what I've made for my dad's radio. And there's some connectors for wires. And as well, the other day I made a little stand for his radio that connected, and now it can stand up a bit higher, and you can move the little ball joints around to different positions. So it's just a really nice tool with the designing and slicing software. Just software is often the hardest part of it because you have to get it right. You have to make sure everything's correct with your design. But once you get that down, it's all good from there. Now I believe we'll open it up to questions.
Yeah, right before you do the questions, talk just for a moment, if you will, about the competition,
Design, yes.
competition concept.
So back to my computer, there's designs competitions, which are nice. So one online program, My Mini Factory, it gives you design competitions where they will give you a thing they want to design for. So right here, it's this weird circle phone, and you're trying to make a case for it. And if you win, you get a 3D printer, which is nice. But there's another one, it's literally just a list of 3D printing. Here let's see, you can design robotics related projects and get gift cards. Here was one, you design a phone for the future and you win 3D printers. And then there's other ones with like instructables. So with that, you build a design and then you have to make a little video about your design, which is a bit intriguing. And so here, let's just go into this one. So in this one, I believe you design a fairy tale, little fairy tale thing, and then you have to take a multitude of pictures of it to send it into them. You can do it just off of Tinkercad here. If you go into Tinkercad, it gives you the design and you can just screenshot from different angles for a picture. So you do not have to have a 3D printer for these competitions. You just have to design it. So as it says, like, it will give you a bit of context for your design, and then it'll give you places if you place. One of the nicest things about this is it's not so much it is a bit of a challenge, and usually it helps you sharpen your skills with the design process, which will be nicer for when you want to design something for yourself. Like here, this little wire connector I showed you guys earlier, it took me 10 minutes to design, and it was quite nice and easy because I've worked with Tinkercad for a while, so I know where everything is and how it works. So
Really
now
great.
I believe we will go on to questions.
There you go. Thanks so much for that. So I put a thing on the chat. Do you have any questions? Greg had one, and I'm going to open his mic here because you might want to ask it. Greg says, does the arrow mount print use internal support structure? Go ahead and ask that question or ask anything else there, Greg, and let's see if we can get an answer.
Well, you've already asked the question there. So
Okay.
you have that internal square hole going through it. And it seems like to keep the top from sagging during the print, you need the support structure. Is that true?
Yes. So if you have something like here, if I printed this sideways, I'd have to have little supports inside of each little hole because it has an overhang of over 45 degrees.
Right.
And that will make it so it stays strong, because if you didn't print it with supports, it would be all squished and down, and it would mess up your print quite a lot.
Right. But that one obviously is going to be printed flat.
Yes.
So you don't have that issue.
So in the arrow support, since they have a solid, they have a hole on basically every side. Some parts of the holes will have supports in it. Like the bottom, they'll most likely stick the rectangular part straight up, so they don't have to print supports in that. And then you'll have less supports in the side holes, which will be all filled in. And once they print, you can usually just poke the supports out very easily.
Okay.
Tom or Ken, anything you want to add to that?
Yeah, this print is printed vertically. I thought about that last night because these other mounts were printed horizontally. And you're right, the infill, you need an infill in this hole or it will collapse. Now, that's not always true though. I have some that will print. I can print and bridge that gap, no kidding, without it slumping. How? It's just all a temperature and speed thing. You get the right temperature and speed, it'll do it, and it'll cool, and it'll be straight. It's kind of amazing. But no, that one needed some support. That's why I've chosen to print this one vertically. And I paused this earlier for a minute or two just to see if it would start again. And it did. And I showed you the infill. I can pause it again to show you that these parts may appear solid. I guess when we look at anything, we assume that it's a solid piece or something. But in fact, it's not. And it does still have the integrity of something solid. So, yeah, these mounts too. This mount is taking that.
Oops.
That press and fitting really takes all the brunt of all this weight. I mean, this antenna is quite a bit of weight. So all that energy is focused right on that screw point. So that's why I opted to use epoxy. I tried, I put one of those press-in fittings and it just pulled out because the thing, you know, there again, it's 4 feet long and it probably weighs 20 pounds. So.
And that could be a factor of your infill setting. You can print these models absolutely solid if you want to. It'll use more filament.
Sure.
Or you can just adjust that down. So when I'm using a heat insertable mount like that, I have to increase the infill, at least in the portion of the model where the insert is going to be.
Oh, absolutely. Yeah, that helps a lot. But there again, you can print it solid. It's I don't know, unless you're making blocks to hold up your car, it doesn't really need to be. But the infill, I mean, it adds a lot of strength, and you can change the number of wall count, how many times it goes and makes a wall outer surface. And that also adds strength to the model itself. But the orientation, like Hunter was saying, is very important. You've got to think about this thing printing topographically. The thing only goes up. It doesn't go back downward to make print. So the less support structure you can do is the better. Support structure takes a lot of time. And if you can manipulate the object to a different angle to make it print quicker or sturdier, that's what I tend to do. Like this one, I printed vertically because I didn't want to print, it would take another hour to print all that support for that hole. Back to you, Ken.
Okay. I wanted to just put a bug in everybody's ear that you don't have to have a plastic part at the end. For example, you can buy plastic filament that is infused with ceramic dust. So once your plastic model is printed, you can put it in a kiln and fire it, and now you have a ceramic part. So imagine the benefits to the ham radio enthusiast for making ceramic insulators. And that's just one thought I wanted to send out to everybody. New filaments are being developed all the time, and it's just a great market and a great hobby.
Okay, thanks. Let's take one more question, and then we'll close do a couple wrap up and close the normal session. Then we'll have a separate Q&A session in case anybody has to leave. Thanks for that question, Greg. Let's go to Brian, KJ6EAC. I have your mic open. You asked the question, what is the layout to make something like a figurine? You want to say a little more on that, Brian?
Yeah, I'm just curious, when you're designing, doing the rectangles and stuff, pretty obvious, you're just building it up. If you're doing a figurine head animal, what's the software like to do all that? Whichever one of the three.
And I think Tom has some examples of some figurines there. You want to go off mute there, Tom?
Yeah, let me unmute here. Yeah, I didn't design this. This was gotten off the internet. I wanted something to put on the top of my flag, outside, so I wasn't just so lame. And but there are different softwares for artistic modeling. There's quite a bit of them, and you can do some amazing things. Unfortunately, I've been kind of wired and programmed to stick to the engineering side of things, but yeah, you just have to Google that for making like facial or artistic models. But there is web-based design softwares like what Ken was showing you, but for more artistic stuff. And I'm going to look into that again. Another thing I wanted to show is the lithophane.
Show that. That is very cool.
Lithophane is, I guess we used to do this back in ancient times, and chisel marble, something, white and transparent. Now we can do this in plastic. And what the idea is here that it reduces material and allows light to pass or light to be blocked. So this is my little Boston Terrier. It doesn't look like much, does it? It's just kind of a, white piece of plastic with some sort of shape to it. Now, you hold this up to the light, and you get a whole different, I can see that very well, sorry. But it basically makes a black and white image. So that's another aspect, going beyond ham radio and 3D printing is this wonderful aspect. You can print family photos and whatnot.
Just tell us one thing about this, and that is, what do you do? Shoot a picture of your dog and somehow get it in the software with a template or something, and then all of a sudden this thing prints? Is that kind of the gist to it?
Absolutely. Yeah, it's really easy. I'm trying to think if I can find my software. I can put it up on the screen, but yeah, it's really easy. You just take a photo and you put it in there. You have to adjust some settings, very easy. There's a few videos on YouTube, and they really, when doing these printers, YouTube and the internet are your best friends because people have already been through the struggles. I guess also Facebook. nah, I don't care for that. But YouTube has so many videos. If you have if you're stumped on something, or just putting the thing together. Like if you don't want to do this blindly or by the instructions, there's half a dozen people that have assembled these and really take a lot of the learning curve out of 3D printing.
Okay, does that help you, Brian? Okay, he's off mute. Okay, I'll tell you what we're going to do. We're going to begin to close it up, the normal meeting, and then we'll open up a separate Q&A. The Q&A can be around 3D printing because we got our specialists here today, but if you have some other questions regarding ham radio or the club or anything else, we'll stick around to answer it. I want to thank our 3 esteemed experts today, Tom, W6XX, Ken, K7KBJ, and Hunter, KJ7IRS. Okay, let's do a poll here. The poll should be open. It says, on a scale of 1 to 4, how interested are you learning more about 3D printing, like another virtual event, training, something in the future? So give us a little bit of idea on that. Okay, quite a bit. Oh my gosh, pretty interesting. We'll get the okay, I'm going to close the poll now. It's pretty significant. So the results show nobody said none, 11% said little, 64% medium, and 25% said a lot. So quite a few people are really interested in that. That's super good. We have one other question, and that is, assuming we have a ham fest in person someday again, I don't know when that will be, whether it's an NVCon or something else. The question is, on a scale of 1 to 4, how interested you in having a workshop in some future ham fest? So that would be an in-person event, assuming once we get there. Okay, the numbers are coming up. It's not quite the same, but it's kind of similar to the question on the virtual. Yeah, we'll get this up here. So here we go. We'll end the polling and we'll show the results. It's very similar, not identical, very similar. It's the highest part is medium. Okay, sounds good. Well, thanks to everybody today. We'll stop this recording, and then those that need to leave, they can. Then we'll go into the Q&A sessions. This has been 3D printing applications for ham radio and beyond for the SNARS monthly media on August 1st, 2020. Thanks.